Hey Daniel, why you holding the spanner like that?
Why? Is it wrong?
So Daniel, do you know about the moment of force?
Yes, I know. Moment is product of force and perpendicular to distance from the line of action where it is from the pivot. So if I'm not mistaken, the equation is moment equals to F multiplied with D, where F is force and D is distance. But I don't know how to apply it.
Let me add a bit information for you. So the unit for force is in Newton, and the unit for the distance in meter, and the SI unit for the moment is Newton meter or Nm. And since the moment is a vector unit, it has both magnitude and the direction, where usually the direction is in anti-clockwise and clockwise.
So how can we apply it in this situation?
Okay Daniel, let me explain to you. Since moment is depend on the size of the force and the perpendicular distance from the pivot to the applied force, so instead of holding the spanner near the pivot, you should hold the spanner far from the pivot. The greater the distance, the greater the moment. So is it easier to loosen or tighten the nut?
So what you're trying to say is, instead of I hold the spanner in here, I should hold it right here.
Yes, that's what I mean.
In order to better understand, let's look at the example 1. Find the moment about A, where for each point, force equal to 5 Newton. Let's look at the diagram here. We can analyze that A was the pivot. To find the moment about each point, let's recap the formula for the moment. Moment equal to force times distance, where the unit for the moment was Newton meter. For point A, moment about A, 5 times 0 equal to 0 Newton meter. For moment about B, equal to 5 times 3 meter equal to 15 Newton meter. And the moment about C was 5 times 4 meter equal to 20 Newton meter. That's all for the example 1.
Wow, yes, it's much easier and much faster for me to loosen it. Earlier it was so much hard and so much taking time. I really appreciate your concern, your knowledge. So thank you so much. I salute you. Welcome.
Hey Rosette, look, there's seesaw. Let's play together.
Let's go.
Go.
Hey. Well, I just did Facebook. Yeah, it's about principle of moment. Do you know about it?
Rosette, can you explain about it? I'm interested to know about it.
Okay, let me explain to you. The system is called in equilibrium or balance if the total sum of the anti-clockwise moment is equal to the total of some clockwise moment. When the system is stable or balanced, it is said to be in equilibrium as 0.
Oh, so you mean all the force acting on the system and the resultant force in any direction is 0. I see. Thank you, Rosette, for the explanation. Rosette, this seesaw seems like unbalanced. So how can we balance it?
Oh, that is a good question. To balance the seesaw, we need to have the same weight and same distance from the pivot. But if we have the different weight, we need to adjust the distance from the pivot.
Let's do the calculation.
To understand more about the principle of moment,
Let's make some example. Given here, ball A and B with the different weight. Ball A with 15 kg and B with 20 kg. So how far from the pivot ball B should be to balance the seesaw? If the pivot to ball A is 3 meter. So when we say about it should be balanced, the moment is equal to 0. So we just calculate the moment for the both ball and plus it. So we can find the D, and the answer for D is 2.25 meter. So the distance from the pivot to ball B is 2.25 meter. So the seesaw will be balanced.
So in conclusion, firstly we can conclude that moment is equals to F multiplied with D, where F is force and D is distance. And unit SI we use for moment is Newton meter and M. And moment is unit vector. Unit vector means that the vector with magnitude 1. So, and the second conclusion, the larger the distance or the larger the force, the more moment will be produced. And the third conclusion, we can conclude that principle of moment is called in equilibrium or balance.